All right, guys, we are back for section 5 of criminology, and today we're going to talk about some of the more modern biological theories. In the last section, we talked about kind of the early biological theories and how they were essentially just a giant excuse for racism. But that doesn't mean that the entire field of biological criminology has been kind of debunked or is no longer studied. It just means we do it in a much different way today than we used to back in the late 19th and early 20th centuries. So here's our funny internet picture of the day. So yes, that is true. Eucalyptus, if you eat it, does cause a hallucinogenic effect, and it's the only thing that koalas eat. So all koalas are just kind of constantly tripping, which I find just really weird. But anyway, they're cute. All right, so um, we talked about Goddard last time, right? The guy with the IQ tests and how he was trying to say that IQ is immutable, unlike Binet, who was the guy who actually developed the IQ test. The Goddard guy thought that, if you were stupid, if you had a low IQ, I should say, that was permanent and unchangeable, and it's hereditary, right? So he did this study of a family that he called the Calicax, which was a pseudonym that wasn't actually the family name. But he found that if you look at this chart, the black circles are the people who are in, I don't want to say all of them were in institutions, but all of them had developmental problems and a low IQ. Goddard contained, or not contained, Goddard believed that this was proof that low IQ was hereditary, and thus, if we wanted to kind of make humanity smarter, we needed to sterilize these people with these low IQs to prevent them from breeding and, coloring the gene pool, if you will. There was a similar study done by a different researcher with the Jukes family that instead of looking at IQ, looked at criminality. This was the Jukes family in the late 1800s. And essentially they found that every generation of the Jukes family had, most of the people in that generation had gone to prison at some point or were in prison at that point. And again, this was used as kind of proof that criminality is inherited. We need to have these not stereotyping, but sterilizing programs to keep these families, these criminals, these mental defectives from breeding. It wasn't perfect. They obviously noticed that not everybody in both of these families was either a criminal or a mental defective, but they did find that the mother was more influential than the father, right? So if you had a low IQ mother or a criminal mother, you were much more likely to be mentally defective or criminal yourself. Now, I'm hoping everybody watching this can see the giant glaring flaw in the arguments made by these researchers. Every generation of that family was growing up in the exact same environment as their parents did and their parents did. So the vast majority of this, if not all of the criminality and the low IQ, can be explained away by things like fetal alcohol syndrome, poverty, how you're raised is a much more impactful thing than who your parents are. So, luckily, at some point, they kind of realized, yeah, that's not a very good argument. We can explain this generational low IQ and generational crime through a much easier, much better explanation with things like poverty, fetal alcohol syndrome, like all these other things that are absolutely generational, and we can kind of display and exhibit and show the evidence for that much more easily than we can that there's any kind of biological link that's causing these problems generation after generation. So, how do we kind of control for environment? Well, the first thing they did was look at twins, right? And there's two different kinds of twins. There's monozygotic and dizygotic. In common parlance, monozygotic means identical twins. These are two children that come from one fertilized egg. These two are genetically identical. Dizygotic twins are fraternal twins, i.e., two different eggs that got fertilized at the same time, and the mother just happened to be pregnant with two kids at once. These two are no more genetically related than any two regular siblings, right? So, if we look at the concordance rate, which is how fancy criminology people talk about if one of those twins is a criminal, what are the odds that the other one is a criminal, right? If crime is not biological at all, this kind of controls for environment, if they're raised the same way, if one twin is a criminal, are the odds of the other twin being a criminal increased or decreased or what? And if the concordance rate is different with monozygotic and dizygotic, that would kind of give decent evidence for whether crime is biological or not. Interestingly, the monozygotic twins do indeed have a higher concordance rate than the dizygotic twins, the fraternal twins. Which means that there might be something to this whole biological influence on criminality thing. The next thing they did was they looked at adoption studies, right? So if you're adopted as a child, then obviously your genetics and your environment are going to be disconnected, right? You won't have the problem that the Kallikaks and the Jukes had, where each generation was raised in the exact same environment, so the biology and the nature and the nurture were kind of indistinguishable. If you're adopted, then your biology and your environment are theoretically kind of randomly assigned, right? And what they found was, yeah, there is a little bit of biology. If your parents are criminals, you are a little more likely to be a criminal, even if you're adopted out to a different family. Now, the big hit against this study is that, or these studies, I should say, is that people don't, the adoption agencies do not give babies to parents that are vastly different from the baby's biological parents. Babies tend to go in adoption agencies to parents that look roughly like what the biological parents look like. In a lot of ways, right? Obviously not in every way, but in a lot of ways, and not in every instance, but in enough instances that this could have affected the outcome, right? So the best way to study this that we found, the best way to actually measure if there is some kind of biological input to the whole crime problem, is to look at twins separated at birth, right? Especially monozygotic twins separated at birth. So there was a big study where they found, I can't remember, it was like 130 different sets of identical twins separated at birth and adopted by different families, and they had no knowledge that the other existed growing up, right? So now we have these genetically identical people that have the exact same biology, but vastly different environments that they grew up in with no knowledge of the other. So what is the odds, if one is a criminal, what are the odds that the other becomes a criminal? Again, what's that concordance rate? And surprisingly, they found an even higher concordance rate than they did in the first twin studies up there, right? So why? Why, if one identical twin is a criminal, why does the odds of the other one go up so much? That is a really, really difficult thing to answer, and there are a lot of different kind of ideas about why this might happen, right? Another thing we have to talk about is genetics. Men and women obviously have very different hormones and hormone levels. And we all learn in kind of, the freshman high school biology that men are XY, they have that genetic pattern, XY, and women are XX. And in the vast majority of people, that's true. But there is a really large segment of the population that is neither XY or XX. And you can see this chart up here has all the possible combinations. And in a few of those, the child never survives, living at any point. But most of these different combinations are actually seen in life, and for a lot of them, you could have one of these genetic abnormalities, I guess I should say, and never know it. One of the more common ones is XYY, right? So you're born, everything looks like you're a normal male. There's very little physical difference between an XYY male and an XY male. The only real difference is that XYY males are taller and tend to suffer from acne in their teenage years more, which is interesting. But that's the only real difference between an XYY male and an XY male. And in fact, one of my anthropology professors when I was in school many years ago thought I might be XYY because I'm 6'8", and the tallest other person in my family is my father at 6 foot even. So I am vastly larger than anybody else I'm genetically related to. And before you ask, yes, I have done a one of the the 23andMe or one of those genetic tests that link you to all your family, and yes, I am blood related to all the family I'm supposedly blood related to. So interestingly, one thing they have found is that XYY males are overrepresented in places like prisons and mental institutions. Why? Does that extra Y chromosome cause some kind of criminal behavior? Some researchers say it does. Some researchers say it causes men to have higher levels of testosterone, higher aggression levels. They're kind of more male than XY males. Others say no, it's because they had kind of an extra awkward adolescence, which is when so much of criminality is kind of ingrained in children because of their extra height and their tendency to have acne and all these other things make their adolescence kind of more disturbing or more difficult, leading to negative coping behaviors that then either relatively soon or later on in life result in them being criminals more, right? So it's not necessarily anything to do with the genetic aspects of it as much as it is the reaction to the physical manifestations of it in a very important time in a child's life. But the point here is that there's a huge wide variety of sexes, which is the genetic information, but also a wide variety in gender. Because as biology and sociology and psychology and all those other fields have been figuring out over the last few decades, is that gender isn't a binary, it's a spectrum. And there's a lot of things that you can put you at different points on that spectrum. So applying this to criminology, essentially what we find is that if you look at that gender spectrum, there are differences in hormones, there are differences in brain waves, there are all kinds of physical differences in the body based on where you are in that gender spectrum. And essentially, we talked earlier in an earlier section about how men are much more likely to be criminal than women, and that isn't a binary male higher rate, female lower rate. If you look at the gender spectrum between really, really feminine over here and really, really masculine over here, it's that as you move towards the more masculine, the odds of committing criminality go up. And there's lots of different ideas and possibilities as to why that might be. Hormones definitely have a big influence on criminality. In fact, we can show that women, they are indeed more likely to commit crime during their premenstrual cycle, when their hormones are much more kind of male than they are normally. So during a woman's monthly cycle, their hormones obviously fluctuate hugely, and when those hormones fluctuate, so does their criminality. So there seems to be some kind of hormone effect on crime and criminality. Same thing goes with dopamine and serotonin. And when you get right down to it biologically, dopamine and serotonin are the only things you technically actually like. Anytime you get a good feeling, you're happy, you're excited, all those positive emotions, those are caused by either dopamine or serotonin in your brain. And the amount of dopamine and serotonin affects criminality. So dopamine has a curvilinear relationship, which means if you have way too little dopamine or way too much dopamine, your criminality goes up. But if you have, just kind of the right amount of dopamine, your criminality is way low. Serotonin, it's a negative relationship, i.e. as your serotonin goes up, your criminality goes down. So a lack of serotonin can be shown to be associated with criminality. Now, is it causal? Remember, we talked in section 1 or section 2, about the difference between a correlation and a causation. Everything I've described on this slide is merely a correlation. We can't know for sure whether it is actually causative until we look at potential spurious relationships here. There might be some other factor that's affecting all of these things, right? Or some middleman, if you will, between high hormone levels and criminality. There might be, a whole bunch of other steps in that chain, or there might be one thing influence. I mean, there's lots of different explanations for why we see these correlations. Another thing we see is the brain. The brain is probably the most complicated thing humanity has ever tried to study. And we have spent years and years and years and years and gazillions of dollars trying to study the human brain, and we've learned almost nothing. It is so complicated and so dense and so just weird that we've barely scratched the surface of really understanding the human brain and how it works and all these different factors about it. But one thing we can show is that if you've suffered a brain injury, your criminality definitely goes up, right? Anybody who suffers any kind of trauma to their brain is going to see a rise in criminality. Why? I don't know. Who knows? It's an interesting question, right? What does that injury to the brain do that causes you to be more likely to become a criminal? That's something that brain scientists and criminologists are actively trying to research and trying to figure out. We can also look at brain waves, right? So there's all kinds of different brain waves that people have. There's alpha waves and gamma waves, and I'm not a brain scientist. But you can record and track those brain waves. And what they found is that criminals have a lower level of brainwave activity than non-criminals. And again, why? It's really difficult to kind of understand or figure out why criminals have these different brains than non-criminals. So in addition to the brain, there's what's called the autonomic nervous system. And the autonomic nervous system essentially, don't sick a biology professor on me, but essentially the autonomic nervous system is everything in your body that happens without your conscious thought, right? So your heartbeat. You don't have to constantly think about, oh, my heart should beat. My heart should beat. Breathing. You can consciously breathe in and out, but you don't have to, right? It's just automatic. It happens in the background. That's called the autonomic nervous system. Criminals have a lower level of autonomic nervous system activity or kind of drive than non-criminals. Their heartbeat is slower. They have a lower level of kind of activity in that system. Obviously, it's still high enough to keep them alive. It's not zero activity, but it is a lower rate. And one of the ideas as to why that might correlate with criminality that some people have proposed is a thing called stimulus hunger, right? So a person with a normal, high-functioning autonomic nervous system gets stimulus and react to it in the proper ways, right? Whereas if you have a low level of autonomic nervous system, you're not getting kind of as much, the stimulus you're getting doesn't I guess, satisfy you. This is kind of a weird way to explain it, and a weird concept. But you're not getting enough stimulus. You're not getting enough excitement. You're not getting enough happiness. You're not getting enough like things to make your body go, oh yeah, wow, and adrenaline and all the So if you have that lower level of autonomic nervous system, you might have to do more and more and more things to get your body to kind of pick up and give you that adrenaline and the serotonin and the dopamine and all those good chemicals that you really like in your body. If you have to go farther and farther and farther and farther to achieve that stimulus, that reaction that our bodies all crave, that might be why people with lower level of autonomic nervous system activity are found committing crimes more often. So, what can we conclude from all this stuff? Well, nature seems to have a component into criminality. It is nowhere near causal. It's nowhere near a guarantee. We can't just look at your genetic code or your hormone levels or any of those things and say, yep, that person's going to be a criminal, that person's not going to be a criminal. We can't do that. Nowhere close. But we can say that kind of the nature, that genetics, the hormones, all those things provide a window, a possibility, a range of possible outcomes, odds, right? And we can affect within that window. And nobody's window is definitely going to commit crime, definitely not going to commit crime. Everybody's window is somewhere in the middle. And the earlier we act, the earlier we identify who is at higher risk of offending and who's at lower risk of offending, the more effect we can have. We're going to talk a lot about this later on in the semester, but essentially people's behaviors are set very early in life. And it becomes infinitely more difficult to affect people's behavior after a certain age. So the earlier we find kids who are at risk, the more we can kind of make sure that they stay away from crime within that window that they've been given by their biological situation, if that makes sense. Anyway, that is the end of section 5. Hope you enjoyed it.